So let me share the content. Yeah, before starting the class, I would like to say that I have given the link for Google Classroom to you so that I can share some content, some documents related to the subject. Okay. Suppose if I think that some topics are necessary, some topics are important for you to memorize, to study, then I will share some contents related to the subject. So that's why some of you have joined the Google Classroom that I shared to you through email, and that email means your RGIPT email. Okay, so if you have not yet joined like that, I'm naming some students. That is Sujit Kumar, Rohan Kuntal, okay, uh, Vedanshi Srivastav, Sumit Sikarwar, Ishan Singh. They have not yet joined. So please join based on the email sent to you. In that email, the link is there for Google Classroom, the joining link. So if you'll join, you can get the documents related to the course. Okay.
Sir, I have yet not received the link for joining the class through my email.
Yeah, there may be one problem that your email ID is not yet registered in this group email, okay, of this class. So they will later on they will register, okay. And once again I will share. Once again I will add some students that have later joined to the group. So then only I think you can be able to, or you can tell your email ID.
Sir, 24 EC3048.
Wait. 24 EC.
EC it is.
ECE.
EC. Just EC.
24 EC
3048.
3048.
Yes, sir.
This one, Sambhavi Srivastav.
Yes, sir.
Okay. Any other? If you want to request, I will
Yes, sir.
send request to you.
Sir, 24 EC 3006.
24 EC
3006.
3006. It is not yet, means this email ID is not yet activated, I think. So later on, if they will activate, then I will add. Okay, no issues. Okay. Any other?
So 24 EC 3038.
3038. This email ID is not yet registered. This is also not yet registered.
Sir,
24 EC 3013.
3013.
Yes, sir.
3029, sir.
3029. Not coming. Wait.
3013.
Wait. First, I am inviting Sambhavi. (24 EC
3013.
3013). Not coming. Three 3038.
Sir, I have a query. Sir, as per merit list, I was allotted electrical engineering. Now, in my mail, it is showing electronics engineering, but I don't want to upgrade my branch to electronics. I want to be in electrical engineering.
Actually, you can contact to academic section. Okay,
Yes.
regarding this, we have no authority for to resolve your query in this regard.
Okay, sir.
You have
Thank
to
you, sir.
contact to academic section. Okay, there is email ID academic@rgipt.ac.in.
Okay, sir.
Okay.
Sir,
Hmm.
actually, I have a query regarding the attendance issue.
Hmm.
Sir, the ability of network is not good in my area.
Hmm.
So, sir, I take the class as a recorded.
No issues,
But,
no
sir,
issues, no issues, no
Sir-
issues at all.
सर लैब में अटेंडेंस वगैरह लगने का कुछ हो
Lab lab is not running in online mode, right? Only
मतलब
class
सर
is. हाँ.
अगर मैं ऑफलाइन उसमें रिकॉर्डेड फॉर्म में ले रहा हूँ लेक्चर को तो उसमें अटेंडेंस में तो कुछ प्रॉब्लम नहीं होगा सर
नहीं कोई इशू नहीं होगा.
ठीक है सर
Okay. So if you are connected for some time also, you can tell your attendance. Okay. We will record. Hmm.
ओके सर
No issues. And also I will try to send you the recorded lecture. Okay. And I will send through Google Classroom some documents related to the lecture. Okay. So don't worry. Okay. So I'm starting the lecture. So this is your first unit. So in fundamentals of electronics engineering, the basic concepts of circuits, firstly we will start. Then in that, I would like to talk about, I will start with basic fundamental that you have already studied in your 11th, 12th, okay? Even starting from high school also you have studied what is charge, what is current, voltage, power, okay? What are the terminology in that? And some information about passive elements, that is resistor, inductor, capacitor. Okay, so in that passive elements, you know that what are the properties of that passive elements means if we talk about resistor, what is that, what is the property of the resistor, what are the types of resistors, and how we calculate the value of resistor, that we already know. Okay, isn't it?
Yes, sir.
Because it is already there in your previous course, before 12th. So just we will summarize the things, and also you know that the series parallel combination of passive elements, also series parallel combination of resistor, inductor, capacitor, how they will be added, how they will behave, okay, like that. In series parallel combination, you know that the property of resistor and inductor is same, right? The property of capacitor is different from inductor and capacitor, inductor and resistor. Okay. So first we will start with the basic fundamental about the circuit elements. Then what are the sources are there, sources available. Okay, we know that we have voltage and current sources available. So there are two types of voltage and current sources. They can be categorized as dependent and independent sources. Okay. So we will see what are the dependent sources, what are independent sources in this lecture. And after that, our ultimate goal is to solve network. Do you know what is network? Have you studied about network previously?
No, sir.
No. Okay, so we will see here in this lecture what is network.
அதோட எனக்கு இது எப்படி தெரியும்
எனக்கு தெரியும் நேத்து மெசேஜ் அனுப்பிச்சு விட்டாங்க
சொல்ல வேண்டியது போனே உங்ககிட்ட தான் இருந்துச்சு நைட்டு
I will unmute all of you.
நீங்க வேலைக்கு ஆகாது ஒரு மொபைல் உங்களுக்கு வாங்கி ஏன் class இல்லாம
Okay, so I will start with basic fundamentals about charge, what is charge, current, voltage, power, then different types of sources available. Okay, then we will see about the circuit solving techniques. Firstly, we will study about, and you already studied, I hope, about the Kirchhoff's law. You know that the Kirchhoff's current law and voltage law, there are two types of Kirchhoff's law that is helpful in solving the circuit or network. So I was talking about the network. What is network and what is circuit? So later on also I will repeat. In the initial stage, I'm telling that what is network. Network is an interconnection of various elements and sources. Okay. The interconnection means the combination may be in any sequence. So that the combination of elements, passive elements and sources all together is called as a network. Okay. If we arrange passive elements and sources in a sequence, and if we connect through wire, so all together it will constitute a network. Okay. Circuit is very similar to the network. Circuit, the difference between circuit and network is circuit must have a closed path. Closed path means in all branches of the network, there must be current flowing. If there is no current flowing in any branch, it means it is not called as a circuit. Okay. So there is a very basic difference between circuit and network, that circuit is a network which have closed path. Network may or may not have closed path. Okay. So it means every circuit is a network, but every network is not circuit. Okay. So this is very basic difference between circuit and network. So ultimately in this unit we will see, after starting with the fundamental concepts, we will study about the different methods to solve a network. Solving network means to find out the current and voltage values in the network. We know that the current can be evaluated in any branch. Okay. Means the current can be evaluated in any branch and it will be through the branch. Okay. And the voltage will be across any two terminals in the network or circuit. So we have to calculate the current and voltage ultimately. Okay. So to find out the current and voltage in any network or circuit, there are many ways. So that we have to study. There are basic theorems also, basic concepts also. So first basic concept is Kirchhoff's law. We can solve the circuit by using Kirchhoff's law, means KCL and KVL. KCL is Kirchhoff's current law. KVL is Kirchhoff's voltage law. Okay. After that, we have the two other methods also, nodal and mesh analysis, that we will study later on. Then the final topics regarding the circuit solving is network theorems, that we have to study. And we have seen in the syllabus also that we have to study 4 network theorems: superposition theorem, Thevenin's theorem, Norton's theorem, and maximum power transfer theorem, that we will study later on. So I will start with basic fundamental concept. What is charge? You know that charge is an electrical property of atom, that particles of which matter consists, and it is measured in coulomb. So you know that the electric, it is the most basic quantity in an electric circuit. Okay. And you know that all matters are made up of fundamental building blocks known as atoms. So each atom consists of electrons, protons, and neutrons. So the charge of electron means we can calculate the value of charge of electron, proton also. You know that the electron charge is negative, proton charge is positive. So electron charge is equal to minus 1.602 into 10 to the power minus 19 coulomb, that you have already studied, and the same value with positive sign is for proton. So in this way we can see that the 1 coulomb of charge, in 1 coulomb of charge there are okay. So in 1 coulomb of charge there are 1 upon 1.602 into 10 to the power minus 19 electrons. Okay, we know that the charge of electron is minus 1.602 into 10 to the power minus 19 coulomb. So in 1 coulomb there will be this much electrons, means 6.24 into 10 to the power 18 electrons, that you already know. Next is based on the charge, there are some examples how much charge is represented by 4600 electrons. We know that the charge of one electron is 1.602 into 10 to the power minus 19 coulomb. So charge of this much electrons will be multiplied by, that means 4600 multiplied by 1.602 into 10 to the power minus 19 with negative sign, because we know that the charge of electron is negative. So we can calculate accordingly. Next is the calculate the amount of charge represented by 6 million protons. We know that the protons have positive charge. So we have to multiply 6 million with 1.602 into 10 to the power minus 19. So we will get this much coulomb charge. Okay. Next is the current. We know that the current is rate of change of charge with time. So electric current is the time rate of change of charge and it is measured in ampere. Okay, you know that the net amount of charge that passes through the wire per unit time. Okay, so the 1 ampere is 1 coulomb per second. We know that I is equal to dq by dt, that is the rate of change of charge with time. So I is equal to dq by dt means coulomb. The unit of current can be coulomb per second. Okay, so the unit of current is ampere, measured in ampere. So ampere, 1 ampere is equal to 1 coulomb per second. Okay, if the current doesn't change with time but remains constant, we call it as a direct current. We know that there are two types of current: direct current, that is DC current, and alternating current, that is AC current. Okay, so if the current is not changing with time, it is a direct current. The value will be constant throughout the time. Okay, and the common form of time varying current is the sinusoidal current or alternating current, that you can see in the below diagram. And the AC is a current that varies sinusoidally with time. So you can see that the value is varying sinusoidally with time. So the direction of current we can see here in these two diagrams. You can see that this is a wire. In this wire, the current is flowing in the upward motion here. It is shown. In this, in the figure 2, figure B, the current flowing is shown in the downward motion. So it means the current is, the direction of current is reverse here. The same amount of current can be seen in both wires in figure A and B, but as per the direction, you can see that this has considered as a positive current value. Due to the reverse direction of the current, here the current value will be negative, right? So the direction of current flow is conventionally taken as a direction of positive charge movement. So in figure A, the direction of arrow and the value 3 ampere indicates either that a net positive charge of 3 coulomb per second is moving to the right, okay, the right direction. 3 ampere means 3 coulomb per second, we can call, okay, and the net negative charge of minus 3 coulomb per second is moving to the left each second. So this can also be considered as, if this is moving right, 3 coulomb per ampere, 3 coulomb per second, if this is moving in the right direction, this can also be considered as minus 3 coulomb per second is moving in the left direction. Okay, so that can be observed from figure P. Okay, so in figure B, you can see that there are again two possibilities. Either minus 3 ampere is flowing to the left or plus 3 ampere is flowing to the right. Okay. So based on the current, there are some examples taken here. The first example is the total charge entering a terminal is given by Q is equal to 5t sine 4 pi t millicoulomb. We have to calculate the current at t is equal to 0.5 second. So we know that the charge is given, we have to calculate current, and we know that the current is, the equation of current is I is equal to dq upon dt. So means with respect to time, we have to differentiate q. So I is equal to dq upon dt, that is d upon dt. This is q, 5t sine 4 pi t millicoulomb. So 5t sine 4 pi t millicoulomb per second. So if we differentiate, we can get this much milliampere current. So at t is equal to 0.5 second, means at this particular time, we have to calculate the value of current. So we will put the value of t in this equation. Okay, so I is equal to 5 sine 2 pi plus 10 pi cos 2 pi. So that will be sine 2 pi is equal to 0 and cos 2 pi is 1. So you will get 10 pi. The value will be 10 pi, means 31.42 milliampere. Similarly, in example 2, if the Q is equal to 10 minus 10 e to the power minus 2 t millicoulomb, find the value of current at t is equal to 1 second, that you can solve very easily, just like by using this equation, I is equal to dq upon dt. In third example, you can see that we have to determine the total charge entering a terminal between t is equal to 1 second and t is equal to 2 second. Okay, the current passing through the terminal is I is varying with time, that is I is equal to 3t square minus t ampere. So you know that if I is dq upon dt, so q can be written as integration I dt. Okay, and the limit will be t is equal to t0 to t. Okay, so you can see here the q can be calculated as integration initial value of time to the final value of time I into dt. Okay, so initial value is t is equal to 1 second, final value is t is equal to 2 second, and we have to put the value of current here, 3t square minus t into dt. So by integrating and by putting the limit values, we can solve easily, and we are getting here 5.5 coulomb. That is the current charge value. Okay. Can you hear me, all of you? This is just for confirmation.
Yes, sir. You are audible.
Okay, thank you. So next is about voltage, the third basic parameter. Okay, firstly we have seen about charge, then current, then third one is voltage. We know that it is also called as a potential difference. So it is the energy required to move a unit charge through an element, and it is measured in volt. Okay, so 1 volt is equal to 1 joule per coulomb. Okay, means V is equal to dW upon dQ. That is W is the energy in joule, V is the voltage in volt, Q is the charge. Okay, T is the time in second. So 1 volt is equal to 1 joule per coulomb, and it can also be written as 1 Newton meter per coulomb. Okay, so here we can see in this figure, this is an element, and there are two terminals of that element, and the voltage across these two terminals of the element is denoted as VAB. Okay, so voltage has some polarity. It will be plus minus if it is DC voltage. Okay, voltage can also be DC and AC. If it is DC, it has some polarity, that is plus minus. So based on the polarity, we can see that the terminal A has positive polarity, terminal B has negative polarity, and the VAB is denoted as as per the notation of VAB. We can clearly analyze that VAB is equal to VA minus VB. Means if we have written VAB, it means it will be VA minus VB. It means we have assumed that the terminal A voltage is more positive than terminal V voltage. Okay, so you can see here positive sign is there, here negative sign is there. Okay, so next is based on the plus minus sign, we can see that there is a reference direction or voltage polarity. So VAB means the point A is at potential of VAB that is higher than the point B. So point A is higher potential than point B. Okay, so VAB can also be written as minus VBA. Okay, it is studied. Means here we have denoted as terminal A voltage is positive, terminal V is negative. So it means if VAB is 9 volt, if VAB is plus 9 volt, we can also write VBA that will be minus 9 volt. Okay, based on the polarity, because VBA will be equal to VB minus VA. Okay, we know that VB has negative polarity and VA has positive polarity. So overall, if we subtract VA from VB, it will be negative value. So VBA will be minus 9 volt. Okay. So this is mentioned here, same thing. The constant voltage is called as a DC voltage, whereas the sinusoidal varying voltage is called as a AC voltage. You already know, just like a current. Current can be DC current or AC current. Similarly, voltage can be DC voltage or AC voltage. So the DC voltage generally we can obtain from a battery, whereas AC voltage we can obtain from electric generator. Okay. So if you have generator, means there are two types of machine, motor and generator. So motor utilizes electrical energy and it will convert into mechanical energy, where wheel rotates based on the mechanical energy. Whereas the generator is reverse part. Generator is the reverse of motor, means operation is reverse. Means when there is a mechanical rotation, wheel rotation, the electricity will be generated through generator. Okay, so that electricity generated through electric generator is AC, will generate in the form of AC quantity. Okay, whereas the battery which is available in our houses, okay, which is connected with our inverter, connected in our houses, that battery has DC value. Okay, it will give DC voltage. These are very basic fundamentals you already know. So next thing is power. So you know that the power is the time rate of expending or absorbing energy. Okay, it is measured in watt, and power can be written as P is equal to dW upon dt. It means rate of change of energy per unit time. Okay, so it can also be written as dW upon dq into dq upon dt. We know that dW upon dq is nothing but a voltage, dq upon dt is nothing but current. So it means simply the power is the multiplication of voltage and current, right? So power is simply multiplication of voltage and current, you already know, and it can be defined as rate of change of energy in joule per unit time. Okay, so if there can be possibility of power can be positive or negative. So if power is positive, power has positive sign. Okay, so it is considered as the power is being delivered to or absorbed by the element. Okay, by the element. So if power is positive, it means power is delivered to the element or it is absorbed by the element. Okay, which element can absorb power? Which element can absorb power? Anyone can tell? Hello, am I audible to you?
Yes, sir.
So which element can absorb power? We have three passive elements, na? Resistor, inductor, capacitor. We know that you have already studied that
Resistor.
resistor can dissipate power. Okay, resistor can dissipate power.
Capacitor.
Okay, sir.
So in inductor and capacitor, power can be absorbed. You know that in inductor, power can be absorbed in the form of magnetic energy. And in capacitor, power can be absorbed in the form of electric energy, right? In the form of electric field. And in inductor, power can be absorbed in the form of magnetic field, right?
Okay, sir.
So if power is positive, it means the power is delivered to the element, being delivered to the element, or power can be absorbed by the element. Okay. If power is negative, it means the power is being supplied by the element. Means the power will be the flow of power will be from element to the source. Okay, means power will be supplied by the element towards the source. So this denotes the negative power sign. Okay, when current enters through the positive polarity of the voltage, just you can see in figure A, this is figure A and this is figure B. Okay. So you can see when the current enters through the positive polarity of the voltage, you can see that this is element. Okay. This is element, any element. And if we have assumed the voltage across element, the sign is plus here, minus here. Okay. Because here we can see that the sign is plus minus. Towards the terminals of the element, the sign is plus here, minus here. So across the element, you can see that the plus will be here, minus will be here. Okay. And the current is entering through the positive terminal of the element, right? So in this case, power will be positive. Power is plus minus plus Vi. That implies that the element is absorbing power. Element is absorbing power. However, in figure B, we can see that in figure B, this is still plus minus V, but you can see that the current is leaving through this positive terminal. In the previous case, current was entering through this positive terminal. However, in second case, in figure B, we can see that the current is leaving to the positive terminal. Okay. So in this case, the product of voltage and current will be negative. It means power will be negative. So power will be minus Vi in figure B, and the element is releasing or supplying power. Means element is releasing power or supplying power. Okay. So where it can be supplied? It can be supplied towards the source. It means it is assumed that here source is there. Source can be DC voltage source or AC voltage source, or it can be DC current or AC current. Okay. So power can be positive and negative. If positive power is there, it means power is delivered to the element or power is absorbed by the element. Okay, if power is positive. If power is negative, it means power is supplied by the element towards the source, or power is releasing by the element towards the source. Okay, clear? So we can understand better with some examples here, given examples. In passive sign, we can see that when the current enters through the positive terminal of an element, power will be positive, right? That we have seen in the previous slide. And if the current enters through the negative terminal, power will be negative. Okay. So here in first example, you can see that in figure A, the voltage across, the polarity of voltage across the element, you can see that plus is here, minus is here, and 4 volt is there. Current is entering through the positive terminal of this element. So it means the product of voltage and current will be positive. It means 4 multiplied by 3, that is power will be plus 12 watt, right? In figure A. In figure B, you can see that if we denote the same voltage across the element, this is 4 volt. So you can see that the current is leaving through the negative terminal, that will be 3 ampere. Okay, it means current is again entering, the same current is entering through this positive terminal here. Okay, if the same current will enter with this positive terminal, then only it can leave with negative terminal. This is very basic fundamental. Okay, so it means the same scenario is there. Figure A and figure B both are same convention will be there, and the power will be positive in both cases. Okay, it means we can say that if current is entering through the positive terminal of the element, it means alternatively we can say that current is leaving through the negative terminal of that same element, right? Same current is leaving through the negative terminal. If it will enter with the positive terminal, then only it can leave with negative terminal, right? The same thing is there. So that's why power will be positive in both cases. Understand?
Yes, sir.
Okay, thank you, thank you. In the next diagram, we can see that if we denote voltage polarity across the element, 4 volt will be here, plus minus 4 volt. You can see that the current is leaving through the positive terminal. Okay, here current is leaving through the positive terminal. It is not entering. Okay, it is not entering, just like we have seen in the previous diagram. Here current is entering to this positive terminal. In this case, current is leaving to the positive terminal. It means power will be negative. Okay, and it clearly indicates that power is being supplied by this element. Okay, power is being supplied by this element towards the source. So that's why power will be negative, and the multiplication of this voltage and current, that is minus 12 watt, we will get in this case. Similar thing is that if current is leaving through this positive terminal, it means it must be entering through this negative terminal. Same current must be entering through this negative terminal. So here you can see that the voltage polarity is same. Sorry. It will be minus, it will be plus. It means the current is entering through the negative terminal. Okay, here you can see that the current is leaving through this positive terminal. It means current is entering through this negative terminal. So both are same thing. If current is entering with the negative terminal, so it means alternatively we can say that current is leaving through the positive terminal. Okay, both are same thing. It means again in this case current the power is being supplied by the element towards the source. Okay, that's why power will be negative in this case also. Clear? So this is very basic fundamental concept, and I will share this slide to you through Google Classroom. So later on you can study self. Okay, and if you have any doubt any time, you can ask in the next class, or in the upcoming classes. Okay. So based on that, you can see this is the question based on the voltage. That is the equation based on voltage is equal to delta W upon delta Q or dW upon dQ. So here the current is given, time is given, energy is given in kilojoule. So based on the current, we can calculate charge. We know that delta Q is equal to I into delta T. So multiplication, after multiplying, we can get 20 coulomb charge. And based on that, we can calculate the voltage drop across the bulb. V is equal to dW upon dQ, where energy is given 2.3 kilojoule and charge is 20 coulomb. So after solving, we can get 115 volt. So these are very basic fundamentals. I will share this slide to you so that you can practice these problems, and if you have any doubt, you can ask anytime. Okay, this is the question based on power. Yeah, this is the question based on power. Find the power delivered to the element at t is equal to 3 millisecond if current entering its positive terminal is I is equal to 5 cos 60 pi t ampere. So power delivered to an element. So we can make diagram just like previous cases. We can assume this is our element. Okay. And current entering its positive terminal. Here we have assume plus here, minus here. This is voltage. Plus minus V, same voltage will be there. Current entering its positive terminal, that is I. So I is equal to 5 cos 60 pi t. Okay, it is given. And the voltage is V is equal to 3I in the first case, and V is equal to 3 di upon dt in the second case. Okay, so we have two cases where voltage is 3I in the first case, voltage is 3 di upon dt in the second case, and we have to calculate power delivered to an element. Okay, power delivered to an element. So voltage is 3I, it means the multiplication with I and 3, we can get 15 cos 60 pi t. So the power can be calculated as P is equal to VI, that is 75 cos square 60 pi t. Okay, watt. At t is equal to 3 millisecond, we have to calculate the power at 3 is equal to 3 millisecond, and so after putting the value of t in this power expression, we can get 50.48 watt. Okay. In the second case, we have voltage is equal to 3 di upon dt. So voltage is equal to 3 di upon dt. After differentiating current with respect to time, we can get minus 900 pi sine 60 pi t volt. So power is equal to VI, that can be calculated this much. And by putting the value of t, that is 3 millisecond, we can get the value of power, that is negative value. Okay. So it means power delivered to the element that we can calculate easily. Okay. So I think we have not much time left. So I will continue other topics in the next class. And before that, I will take your attendance. Okay. Ashish Chandra. Abhya Chandra.
Present, sir.
आदित्य आरएस,
Present, sir.
आकाश श्रीवास्तव,
Present, sir.
अखिलेश साहू, अक्षित तनेजा,
Present, sir.
आनंद कुमावत,
Present, sir.
अंकित दास,
Present, sir.
अपूर्व राज, अर्णव कुमार,
Present, sir.
अविनाश कुमार सिंह,
Present, sir.
आयुष कुमार सिंह,
Present, sir.
गौरव तिवारी,
Present, sir.
ईशान सिंह, कृष्ण गुप्ता, मैत्री उपल,
Present, sir.
मुद्रा गुप्ता, पारांजय सोनी,
Present, sir.
प्राची गौतम, प्रज्वल सिंह,
Present, sir.
प्रियांश राज,
Present, sir.
प्रियांशु कुमार,
Present, sir.
पुलकित सिंह, राहुल,
Present, sir.
राजीव कुमार पांडे, ऋषभ आर्या, रोहन कुंतल, एस ऋतिक साई,
Present, sir.
साकेत सुमन,
Present, sir.
हाँ यस, सम्यक कश्यप, संग्राम चक्रवर्ती,
Present, sir.
शशांक त्रिपाठी,
Present, sir.
शुभम रंजन,
Present, sir.
शुभम सिंह,
Present, sir.
सृजन स्वरांकर,
Present, sir.
सुधांशु कुमार,
Present, sir.
सुजीत कुमार, सुमित सिकरवार,
Present, sir.
सुप्रिया,
Present, sir.
सूर्यांश वर्मा, उज्जवल नयन,
Present, sir.
उत्कर्ष कुमार यादव, वैष्णवी,
Present, sir.
वेदांशी श्रीवास्तव,
Present, sir.
विशाल, विशाल वेस्ले वोदू, ओके, यश,
Present, sir.
यश बावास्कर ना?
Present, sir.
ओके, अर्णव कुमार,
Present.
विनीता भाटिया, विनीता भाटिया,
Present, sir.
ओके, एनी अदर?
Yes, sir.
Hmm.
Sir, you did not take my attendance.
What is your name?
Sir, Shambhavi Srivastava, Electronics Department.
Sambhavi Srivastava. Wait.
Sir, one more, sir. Shashi Shekhar Mishra.
Sir, also my sir, Akhilesh Sahu.
Sambhavi Srivastava, Akhilesh Sahu,
And Shashi Shekhar Mishra.
Shashi Shekhar Mishra. Huh? Okay. Any other? Okay. Thank you. You can join your next class. Okay.
Good day, sir.
Okay. Thank you. Same to you.
Thank you, sir.
Recording stopped.